Oy. Okay, so let's take a look at the sheet that I made up. Classify a triangle based on its side. Classify a triangle based on its angles. The sides, we have three types that we're interested. Equilateral, equilateral. That means all sides are congruent. Congruent is the geometry word for equals. Algebra equals geometry congruence. Next is isosceles. Isosceles, whoops, ISOSCELES. Two sides are congruent. And then the last triangle we're interested in is something called the scalene. No sides are congruent. No big deal. We see it a lot, like Pythagoras triangles 3, 4, 5. That's a scalene. But let's talk about classifying triangles based on their angles. The first one we're most interested in is a right triangle. That means we have a triangle with a right angle. That's the symbol for right angle. And we know perpendicular, flip it and change the sign slopes. The next type of triangle we're interested in is something called an acute triangle. We know an acute angle is an angle that's less than 90 degrees. So we might have a triangle, that's, I don't know, 60, 70, 50. All these angles are acute. The next one is obtuse, and that's a triangle with one obtuse angle. Obviously, because the sum of the angles of a triangle equal 180, we can't have more than one obtuse angle. So, for example, if this is 120, maybe this is 10, but that means this is 50. Good. Number two, 2x plus 5y equals 10 is a line. What is the slope, y-intercept, and y-intercept? Well, you can quickly solve for y. So I'm going to leave the y over here. If 2x is positive on the left, it's going to be negative on the right. And then the last thing we can do is just divide everything by 5. And so we have y is equal to negative 2/5 x plus 2. We quickly now have the slope and we have the y-intercept. How do we find the x-intercept? Well, the x-intercept is a point on the point of the x-axis, which means the y is 0. So to find the x-intercept, let y equal 0 and solve for x. So let's see, we have 0 is equal to negative 2 over 5x plus 2. 2 over 5x equals 2. Remember, if it's negative on the right, positive on the left. How do I get rid of a fraction? Well, I'm going to multiply both sides by 5. So I have 2x equals 10. And then divide both sides by 2. X equals 5. This is my x-intercept. And we can make a sketch, actually. We kind of know that it looks something like the y-intercept is at 2, and this is 2, and the x-intercept is 5, and we know that it's down 2 to the right 5. And we could have also found it out using the slope formula. Anyway, let's move on. Number 3, point M is the midpoint. Point M is the midpoint of AB. If M is 2, negative 6, and A is 1, 9, what is the coordinate of B? Well, I'm going to make a little, some kids made a little diagram. Here's point A, here's B, and the midpoint is M. And we knew it was going to, I wrote on some kids' papers that the line was going up, but these are just numbers. But, we want to be correct. So we know if A is starting at 1, 9, and M goes down because the Y is changing to 2, negative 6. Well, by inspection, you can just see how the change is going on. So for example, the change from X is plus 1. That means the change here is plus 1. So this is 3 something. And then we see here we're going from 9 to negative 6. That's negative 15. Whoops. Negative 15, which means that this change is also negative 15, and we have negative 21. So we have point B. I'm not gonna, we can do the fancy way. Is there a formula? Yeah, use the midpoint formula. So we know that the midpoint of A and B is equal to M. And so let's just call this X and Y. So we can technically say 1 plus X over 2 should be equal to 2, right? Because the middle of 1 and what we know is 3 is 2, 1 plus x equals 4, x equals 3, nice. And what's the middle of 9 and y is supposed to be negative 6. 9 plus y over 2 equals negative 6. 9 plus y equals negative 12. And y equals negative 21. Nice. Okay, next point. What is the slope of AM and AB? So let's figure this out and then come to some conclusions about the line, the slope between any 2 points on a line. So the slope between A and the slope of AM is negative 6 over minus 9 over 2 minus 1, negative 15 over 1, or negative 15. What's the slope of AB? Well, the numbers are different, so you think maybe it's a different slope. So you're like, fine, negative 21 minus 9 over 3 minus 1. And we have negative 30 over 2, but you say, wait a minute, that's also 15. Well, that's the idea of the slope. The slope is just a ratio. It's not, it's just a ratio, it's a fraction. So it just represents a relationship between a change in y or a change in x. We see any, because these are all the same points on the same line, the slope between any 2 points on a line is equal. Now let's find the distance. Well, you know what? I told you something in a different video. We can do this really quickly. Let's find the distance of AM. Well, if you think about it, we have the change in y, and we have the change in x. So this is quickly the square root of, this is 225. Remember, it's negative 15 squared. It's not 15 squared negated. So we have the square root of 226, and I went into my calculator, and I figured that's approximately, squiggle line, 15.03, or 15 100ths. And then we can find the slope of AB. With AB, we have the change in y. That's the same thing in the distance formula, y2 minus y1. Well, I just did my y2 minus y1. We have negative 30 squared. And this distance formula is the y2 x2 minus x1. But we just did that up here, so I'm not going to do that again. And so we have the square root of 904. And squiggle line, that turns out to be 30.06, 30 and 6 100ths. And you notice, it's double the length. That makes sense. It all connects. Nice. Number 4, in triangle ABC. Now let's use this idea of using the slope and then quickly getting distance formula. So we have a question in ABC. We have, well, I'm going to make a picture. I'll make a picture first. So we have A is 40, 47, sorry about that, 47. We have B is 22. And we have C is 70. Yeah, 70. We kind of connect it on your on this. I know what it's supposed to look like. On your graph paper, you might say, Mr. Adler, I know it's the right triangle, but you don't know that until you show me formulas and to show proof. Now, how would we prove that something's perpendicular? Well, find the slopes and then show that they're negative reciprocals of each other. Flip it and change the sign. So let's do that first. So what's the slope of AB? What's the slope of AB? So let's see. The slope of AB is, let's see, what do you want to do? Well, it looks like 7 minus 2, 4 minus 2, that's 5 over 2. And then what's the slope of BC? That is, let's see, 0 minus 2 over 7 minus 2. That is negative 2 over 5. Nice. So we know that the slope of AB is, well, yeah, therefore, AB and BC are perpendicular, so it's a right triangle. But does that mean that it's not isosceles? Well, right angles have to do with the angles. Isosceles has to do with the sides, so we need to figure out what the distance is. So I'm going to make this quickly. So I'm interested in if angle B is the right angle, these are the sides I want to know if they're congruent or not. So let's see. Well, we have the change in y and the change in x. So the distance, therefore, is the square root of 2 squared plus 5 squared, which is the square root of 29. And over here, we have the change to y and the change to x, which fits nicely into our distance formula of 5 squared plus negative 2 squared. Well, that's also 25 plus 4, or 29. Nice. So therefore, because AB is congruent to BC, triangle ABC is isosceles. Nice. Very good. Next question. Number 5. Golf range A charges 500 South African rand a month, and 100 rand each time you play. Golf range B charges a flat monthly fee of 1,500 ZAR. Which golfers would you choose and why? Well, let's think about this. This is a linear equation because if we call the first one A, we start off, you have to pay $500 a month plus 100 each time you go. Now, some people say, well, if I don't go? Well, we're going to assume that you like to play golf and you go to the golf course. What's going on with the second course? Well, that could also be a linear function, which is YB equals 1,500. And if I made a sketch, we know that this is, let's start with B. We know this is across like this. This is YB. And, this is 1,500. And then we also have a Y. It starts at 500 and it increases. So this is YA. And the idea is at some point, whatever this is, at some point here depends how much golf. So what we can do is we have two equations, we can set them equal to each other. So we have 500 plus 100x is equal to 1,500. 100x equals 1,000, x equals 10. The idea here is if you play less than 10 times, you should join course A. If you play exactly 10 times, it doesn't matter which golf course you go to. And if you play more than 10 times a month, then you should go to course B. So that's the idea. So these companies are hoping that you don't use the service that much, but you pay like the monthly fee. And maybe you go like 3 times. So you gave them 1,500, but you didn't use it. And that's the idea. And that's how this is a linear equation. Number 6. Now, something we didn't talk about was writing the equation of a line in point slope, which means all you need to write the equation of a line is a point and a slope. So for example, we have a slope of 7, and it passes through point 2, 3. And we can write this as y minus 3 is equal to 7 times x minus 2. You put the minuses in there if these are positive. Once again, the idea is, can we find the y-intercept? Yeah, really easy. Just solve for y. Y equals 3, 7x minus 14. I distribute it, and then I move the 3 over to the other side. If it's negative on the left, it's positive on the right. Y equals 7x minus 11, and therefore the y-intercept is 11. Nice. Number 7, we decided to go to a music concert because we like music. Maybe Olivia Rodrigo is coming to Johannesburg or Pretoria or something like that. We went to a music concert with all of our friends, 12 children and 3 adults. Instead of x and y, I'm going to use C and A, but you can use x and y for your calculator. So I'm going to pull children's tickets C and adult tickets A. And so we know 12 children plus 3 adults, and then it ended up costing $162. In the next scenario, or the next group of friends, it was $122 for 8 children and 3 adults. And the question is, how much does a children's ticket cost? How much does an adult ticket? So how are we doing for time? Good. And so, nice. So the idea is, how do we solve this? Well, we see that the coefficients are the same, the coefficients are the same, and there's the same sign. We're going to subtract. So we have 4c, these go out, equal 40. C equals 10. Take the c and plug it into both equations to see if you're correct. So 10 times 12 times 10 plus 3a equals 162. 120 plus 3a equals 162. 3a equals 42. A is equal to 14. Does that work? You know what we can do? Take the 10. What we can do is, to see if that is the correct answer, take the 10 and the 14 and put it in the second equation and just see if it makes it true. So let's see if that's true. Let's see. 8 times 10 plus 3 times 14. We have 80 plus 42 equals 122. Nice. Good. Next question. Number 8. Solve the following systems. Why do you think they're giving you weird answers? Okay, this time we didn't discuss. So let's take a look at these two equations. So you see y equals 2x plus 4, and you see y equals 2x minus 7. You say, okay, Mr. Adler, I remember from the first day of elimination, they're both equal to y. Let me set them equal to each other. So you go on your merry way, and you're like, okay, 2x plus 4 equals 2x minus 7. And you saw, you get x equals negative 11. You're like, what's going on here? Well, when you have something that's not true, that means there's no solutions. No solution. And what you notice is go, oh, you know what? These lines are parallel, which means they're never going to meet. So visually, you could immediately say, Mr. Outlet, there's no solution. These lines are parallel. Algebraically, when you arrive at something that's a contradiction, that tells you there's no solution to this system. This is a system with no solutions. Now, the next problem kind of looks like a system of equations that are in general form. So you're like, okay, 2x plus 3y equals 7, and you have 4x plus 6y equals 14. And you say, okay, Mr. Adler said circle the coefficients and then multiply the other ones by the coefficient. Take the 6 and multiply the first equation by 6, take the 3 and multiply the second equation by 3. Or you might say, Mr. Adler, all I have to do is multiply this first equation by 2. Let me get my red pen. And I'm going to have, if I multiply this by 2, well, I'm going to have these sixes the same, and I'm going to be able to eliminate the y. Okay, so you're like 4x plus 6y equals 14, and you subtract, make a line through that, you subtract that, and something else weird happens. You get 4x minus 4 is 0, plus 0, these go out, you get 0 equals 0. Whenever you get 0 equals 0, that means infinite solutions. Infinite solutions. And then you discovered, you know what? These were the same equations, just off by a factor of 2, but these are the same equations. I think it looks something like this. Here's the first line, but you know what? Here's the second line. And so you have infinite solutions. Once again, 0 equals 0, infinite solutions. 0 equals not 0, no solutions. And then let's do the fun challenge. Let's see, two perpendicular lines. We have two perpendicular lines, and the first one is y equals 2x minus 3, y equals 2x minus 3, and the second line is y equals negative 1 half plus 2, and they make a right triangle with the x-axis. So I'm going to sketch my first line. It's up 1, 2, 3, and up and 1, 2, 3. So this is kind of like this. And then my perpendicular line is something like this. So this is, this is this line, and this is this line. It's a bad sketch, sorry, but I'm in a rush. Or not really. So this is the triangle. I'm sorry, So this is 2, and this is 3. Okay, we know that this is a right angle. I'm hoping that I have the sketch right. First thing I want to show the idea is, and we're looking to find the area of this right triangle. Well, the area of a triangle is base times height divided by 2. So let's work this out. First of all, I know this point is 0, 2. Okay, and I know this point is 0, negative 3, negative. The question is, first of all, what is this point? So let's see. How do we find the intersection of two lines? Well, they're both equal to y. Set them equal to each other. So we have 2x minus 3 equals negative 1 half x plus 2. Well, you know what I'm going to do? I'm going to go into the world of decimals. I told you to stay in fraction world, and today I'm going into decimal world. If I add, if this is negative 1/2 on the right, it's positive 1/2 on the left. This becomes 2.5x. If this is negative 3 on the left, this becomes positive 3 on the right. This is 5, and then just by inspection, x equals 2. If x equals 2, that means 2 times 2 minus 3 equals 1, or negative 1/2 times 2 is negative 1 plus 2 is 1. Nice. So this coordinate here is 2, 1. Well, let's find the lengths of these sides. We can quickly do the distance formula. Let's do the distance formula because that's what we know. So let's see. The distance here is the square root of the change in x, so 1 minus 2 squared, plus the change in y, 2 minus 0 squared. We have the square root of 1 plus 4, which is the square root of 5. Now, let's figure out the length of the other side. That's easy also. And once again, there's 1,000 ways to do this. But I'm gonna just, because it's the unit of coordinate geometry and distance, we're gonna use the distance formula. So we have the square root of 1, we have 1, x is 2 minus 0 squared plus 1 minus negative 3 squared. That's the square root of 2 squared plus 4 squared, which is the square root of 20. Okay, so we have the square root of 20, and now we can easily find the area of the triangle. The area of the triangle is 1/2 the base times the height. Well, we know from radicals, this is radical 100 over 2, which is 10 over 2, and the area is 5. Good. Another way you could have done it, and I'm just going to show you how to do it, you didn't even need to use this formula. You could have, this was 1, you could have just done this triangle here, and you know that this is 1, and this is 2. So you have a triangle here, and this triangle here is 1, 2, 3. This is 4 by 2, and you have the areas. So this is what's 1 times 2. This is 1, and this is 8 divided by this is 4. Yeah, that once again, 1 times 2 divided by 2 is 1, and 2 times 4 divided by 2 is 4. 1 plus 4 gives you your 5. Thank you. Here's the board. Now I'm cutting off. And we're going to stop it.